before I hand over to Alessandro, I want to say welcome everyone, and thanks for taking the time out of your busy lockdown schedules. Hopefully we can take some value away from this. I know most people here, but for those of you that don't already know me, I'm Leroy Watson, the Associate Director of Corecom Consulting. Corecom is specialist IT recruitment consultancy. We operate across the UK and Europe with a heavy focus on Netherlands. And yeah, Corecom have been hosting the Tech Session series for a number of years now. And really, it's essentially just about building that tech community, a place where people can network, share war stories, and really sort of get inspiration. So hopefully, if you guys have a good time here today, if you could share and support us on LinkedIn, that'd be really fantastic. I guess a bit of housekeeping, if people could maybe mute their microphones whilst Alessandro is speaking. We've got a lot of attendees today. But what I would do is encourage people to ask questions during the chat function, and then towards the back end of the session, we can readdress those questions and really have some engaging conversations. So I don't want to steal Alessandro's fire, so I'll let him introduce himself and yeah, enjoy. Over to you, Alessandro.
Hey, thanks, Leroy. So first of all, let me thank you, Leroy. He reached out to me, what was it, like maybe 2-3 months ago, and he kept amazing communication all throughout the preparation. I mean, I haven't seen this in a lot of people, so it was really like a proactive. It made me comfortable. I think you have also another session after this, and he's a great guy. I think I'll like to work with him on preparing this. So thanks, and thanks Corecom to do this. So well, welcome. So yeah, so I think he reached out to me because I have the t-shirt of Kubernetes. So this is only just one. This is a t-shirt for the 5th birthday of Kubernetes. So because I'm the guy with the t-shirt of Kubernetes means that I must know something about it, right? Or I hope I'll explain why I'm the person that loves to talk about cloud native computing and Kubernetes in particular. So in the beginning, okay, so let's start. I have a bunch of slides. We just have a little less than an hour, which is exactly the time I'm gonna use, but you know that I could talk about this for literally hours, and few friends that are on the call know that I can talk about Kubernetes until their ears bleed, right? So that's so much I love the project. So let me share this amazing software called PowerPoint. So that's I hope everybody can see my screen and can see me as well. I mean, it's I'm Italian, so I complement my speech with gestures. So just keep me in a corner because I might gesticulate a lot, but that's my nature. So please be fine with it. So cloud data solutions, but it's gonna be really a lot about why we are talking about this today, right? So what is Kubernetes? How does it fit in the landscape of computing 2021 and work? How does it fit? How can you benefit from Kubernetes? How does it benefit you? And what is behind and who is behind Kubernetes, right? So down there is some of my affiliations, so not all of them. I work at Microsoft, so I'm by trade, I'm a software engineer. I work for Microsoft for 5 years now, and I love it. And but today I'm not really representing Microsoft. My opinions are my own. I'm an ambassador for the Cloud Native Computing Foundation, but again, like I'm not representing them in an official way. And of course, I hope I represent the communities.
So the top third of the screen is at eye level.
Okay. And I have my own company, Lovelace Engineering. If you ever need a trainer or consulting around cloud native, you can always reach out to me. The company is called Lovelace Engineering in memory of Ada Lovelace. If you ever get to know, she was the first programmer in history, but that's the subject of another talk. So I'm gonna talk about just a little about me because I like to talk about me, but also because it makes sense. Like, I mean, I think I share the same story with a lot of people that approach cloud native and Kubernetes and had the same discovery journey as me. I'm gonna talk about, I of course, like maybe you heard of Simon Simek, the golden circle, right? So we're gonna start with the what, then we're gonna talk about the how, and then eventually the why and the who, which is for me, it's the real core learning that we from today, and some Q&A at the end. Just something about me. I'm 44. I live in Amsterdam for almost 20 years, and I have strong opinions, and I'm not afraid to talk about them. But most important, I'm here because I really love technology, and I've been tinkering from my Commodore 64 to the new Mac M1 that sit on my desk. So I've been through a lot of generations and epochs in computing. So I'm very glad that I was there when internet came along and when all the cloud stuff came along. So I'm very blessed because I was there. I'm a witness of the evolution of technology in the late millennia, and then in the beginning of the new millennia. It's really like a invaluable time for humanity and for technology in particular. So you can contact me. Please reach out to me. There are many ways to get in touch with me, of course. And if you want to talk about philosophy or politics, I'm also game. So that's where I was born. It's Taranto. It's a small town in the south of Italy. It's beautiful, but it's far away from everything. And then eventually I moved to the north, Ferrara, another beautiful place. It was still a bit small for me, but that's where I learned open source and Linux. 20 something years ago, I was part of the Ferrara Linux user group. And it was so funny because we helped everybody to replace Windows with Linux. So I've been around open source since I installed Slackware Linux on floppy disks. I think they were like a 24 3.5-inch floppy disk. And since then, I always been around open source. And guess what? Now I work at Microsoft, not because I changed, it's because Microsoft changed and embraced open source. And all this story is really about open source. All the cloud native technologies, you will see that they are embedded in the open source community, and the whole point is open source. By trade, by education, I'm a chemist. Not that kind of chemist. I never synthesize anything illegal, but I have a background in science. And then about 19 years ago, I moved to Amsterdam. Then I finally could reach my potential because I met a lot of interesting people, and I started to build the tech communities in Amsterdam. Maybe possibly by now, there are 9 years ago, me and other people, we started the DevOps Meetup Amsterdam. It was when nobody was talking about DevOps, and there were very few meetups, and now there are thousands, of course. And since then, I really saw the growth in communities, this desire, especially in a sort of a small country or small community like the Dutch one. There's this need to get together and exchange experiences, information. So I'm really blessed that I was part of the early movement of tech community in Amsterdam, and I continue doing that. I'm the organizer of the Dutch Kubernetes Meetup, which I will talk about in a bit. So let's roll back a bit, right? So it's 2013, about the end of 2013, and then I don't know if you were around, or if you were involved in the container space. There was no container space. I mean, we were just starting to look at containers and look at cloud. 2013, a few years in after Amazon open up their own infrastructure and call it AWS. JKE was starting. Azure probably was still called Windows Azure. It was really every time, right? And then we had this revolution. So for me, IT computing goes in waves, right? So the evolution of IT is really made in big waves, right? So internet, and in our space, in the cloud space, containers represented a small revolution that actually had a lot of repercussion. And I like to talk about history of computing and containers forever, but maybe it's just for another talk. And then at some point, containers were all the rage, and 2013, Docker, the company, was formed, and they popularized the idea of putting your application in a container, literally a shim, a layer around your application that contains all the dependencies. Talk not about Docker. It's hard because we couldn't really pinpoint the preparation of the audience, so this is really gonna be disappointing for people that don't know anything about Docker. But also, if I talk too much about what is Docker, what is a container, it will be too boring for some people. So let's assume that everybody knows what a Docker container is, and feel free to ask me questions later. So Docker containers are this layer around this shim, this protective layer really around your application that makes it portable, makes it self-contained, and faster to run, and so on and so forth. But in the end, they are just processes running on a host. 2013, Docker came along. It was the best thing ever after coffee, and everybody adopted this. And then once everybody adopts something, then you have these maturity problems, right? So when everybody loves a certain technology, now you need to scale the technology to a point where you can make it productive for you, right? So, and that's where I'm talking about end of 2014 and 2015. I was at Red Hat at the time, and we felt the avalanche of technology knocking on the door, and the adoption of Docker was really exploding. And then at some point, the nice folks at Google, they had this great idea of open sourcing what they were already using in-house. So Google really was already using all this stuff for 5 years at the time. So I think they started more than 10 years ago containerizing the application. So but they realized, hey, this is not the core business, right? So Google core business is advertisement. Container technology is just something they have to use, they use because they need to. So they decided to open source it, and they release it on GitHub end of 2014, and that's where to go crazy, right? So Kubernetes immediately started to become a real thing, something that at the time it was not clear who was going to win this, we call it container orchestration wars. At the time, end of 2015, there were competing technologies. Think of Mesos, Cloud Foundry. OpenShift itself was based on a different technology than Kubernetes. And with time, let's say in a couple of years, everybody realized that Kubernetes had a strong foundation. First of all, it is designed as a distributed system from the get-go, builds upon years of experience at Google, as a very strong foundation, is all API centric and so on and so forth. We're not going to delve too much in the details of the technicalities of Kubernetes, but suffice to say, one of the reasons I really think Kubernetes is superior to the competing technologies that Kubernetes is completely open source. So if you look at Docker Swarm or even Mesos, they were in fact technology owned by a single company. So the roadmap was defined, was decided in the closed doors, within the closed doors of these companies, even if it was public and everybody could contribute to the project. It's what we call pseudo open source. So we think it's great, but it's not that great if you think about it, right? So what companies really want is that they don't want to have any lock-in, right? So and Kubernetes offers this freedom from interest, from hidden agendas, and that's why. And that's all. Again, it's my opinion, but and I might be wrong, but I'll be happy to hear more opinions and discuss it. Side. So this is what we saw, right, in this revolution. We started back in the days. I was still in the beginning of I was still installing Linux, on floppy disks here in the left side. So we were really tied to an hardware, and we deployed application on top of a very inflexible environments. Imagine something goes wrong with a bare metal machine, you have to start over and reinstall everything. You can argue that today we got things like Packet that made even metal machines more easy to adopt. But at the time, it was really like go there with a CD-ROM, reinstall the pizza box, the server, and start over. So that was not so, although there was the state of the art at the time, because we didn't develop all the tools we needed to abstract operating systems, to abstract hardware into what we call an hypervisor layer. And that's where the virtual machine was king, and VMware built an empire on it before, or more or less right before Amazon started with AWS. VMware was literally owning 80% of the market, right? So, and this phase in computing lasted for quite some time, right? So, and we still working on it. I mean, we still use this paradigm for example, in infrastructure as service in the cloud. And this was great. People made a lot of money out of it, and that's great. We still use it, but we were still missing, that agility. You still have to virtualize all the CPU RAM, and you have to virtualize a lot of stuff. It's easier to start over, right? So you can just spin up a new virtual machine or re-image the existing virtual machines and put your app on top, which is great, but it's still not right there, right? So, and that's where Docker started working. Docker really just put together some technologies that were already there. So containerization based on, for example, on LXC in the beginning, then they developed their own container runtime. But all this stuff were already there. So Docker really didn't invent anything. They did invent some part of it, of course, like the Docker Hub, for example, was never there before, and Docker Hub is actually central. The image registry is central to the ease of use of containers, Docker containers in particular. So this was what happened, and then bam, everybody started using containers because they are fast, they are easy to use. Your application is completely containerized, which means it doesn't interfere with the dozens and hundreds of other applications running on the same host. So I'm utilizing my host almost perfectly. There is only a very, very little overhead of running all the tooling of in useless or less than useful activities like emulating RAM. So I'm using completely what I have. So all my hardware is completely utilized, and there's no it's not a chance that the first adopters of containers were service providers, so people that resell, companies that resold their to third parties, because that means that they could squeeze more customers into a single server, right? So if you eliminate all the extra stuff and you make sure that no customers can interfere, can read each other data, that means I have more density, and my revenue, and for service providers, revenue is really a low margin business. Revenue can go up because I can just put more stuff into in one machine. One of the advantages of going into containers, and you'll see it also, of course, is also the advantage of adopting Kubernetes, better resource utilization. So yeah, everybody loved it, and that's why everybody adopted. But now is the problem is shifted from, okay, we all love containers, it runs on my laptop, now I need to scale it, right? So this maturity problem, technology is so good that it may become victim of its own success, and that's where container orchestration started to pop up and to adapt to this new container landscape, and that's where Kubernetes started to Kubernetes became the de facto open source container orchestration. So what is Kubernetes? It's very simple. Kubernetes is an open source container orchestration system for automated computer application deployment, scaling, and management that says everything and nothing in one go. So it's really software, right? So Kubernetes is a software, you can download it. All the source code is on GitHub. It's managed by, it's technically, you can say it's owned by a foundation. It's trademarked, so please don't use Kubernetes in your the word Kubernetes in your products, because the lawyers of the Cloud Native Computing Foundation will find you and will make you pay. So Kubernetes, not because they want to make money out of it, it's because they want to keep the project and the ideas free and accessible to everybody, so nobody can appropriate the name and the source code as well. I mean, you can't really resell open source. You can build a product on top of it, but you can't really make it yours. It belongs to the foundation, and then by extension to humanity. And it's meant to automate, so manage your applications at scale, right? So say that you have a very, very fancy or very old school banking application, and you are now deploying on a set of servers manually. You can give it to Kubernetes, write some wrapping code around it. I promise myself I will not show you any YAML, which is the language where in which Kubernetes express these applications and services and everything that goes around the application, but I might have to show you at least one. So Kubernetes takes your application and helps you put it together and run at scale. That's the core of it. And if you have a takeaway from this presentation is this, that Kubernetes is just software that is helpful to run other software. So it's not the end game. It's not what it's not gonna help you writing your application, but it's gonna help you running your application. So it solves a lot of problems like service discovery and access to the application and so on and so forth. So we all love it because instead of solving the same problem all over again, and for every different cloud or every different environment, we solve the problem once, and we just repeat it for every Kubernetes we run in any cloud and any environment. So this is how you pronounce it?
Kubernetes.
It's a Greek word. My Greek friends, they told me how to pronounce this. Well, stop it there. So me being Italian, I'm not that far away. Actually, I'm from a place that was very close to the Greek word. And okay, stop it now. So it is pronounced Kubernetes, not Kubernetes or Kubernetes or anything. It's you pronounce every vocals. Okay, we got that. So it's an orchestrator, right? So as a director of orchestra, like Muti in this picture, it coordinates computer systems so they can do the work for you, right? So it takes your application and put it in different nodes and different possibly regions and provides the storage. So orchestrate all these things in a coordinated fashion. It's actually the whole point of Kubernetes. So somebody told me a few days ago. So really Kubernetes is, it means helmsman. Sorry. So Kubernetes is a Greek word that means the person who steers the ship, which is not always the captain. It's the helmsman, right? So usually the captain doesn't steer the ship. It's a different role. Big ships have specialization, right? So there's a guy or a girl, somebody that steers and somebody that gives the direction. So Kubernetes really is helmsman. Is what it means, the helmsman. So, and Kubernetes is really, and somebody told me we had a discussion. So it's 4 binaries. It's 4 simple binaries written in Go. Golang is a language developed, guess what, at Google. So that's why they wrote Kubernetes in Go. And it's really just 4 binaries. The 4 binaries are the API server, the controller manager, the scheduler, and the kubelet. And that's it. So the container runtime, which most of the time is Docker, or if you are aware, CNCF, the Cloud Native Computing Foundation, has a bunch of projects under their umbrella. One of them is a container runtime. It's not really a competitor to Docker. It's kind of an alternative to Docker, and it's called Containerd. And it's not part of Kubernetes per se. So the Kubernetes core components are 4: the API server, the controller manager, the scheduler, and the kubelet. So literally 4 binaries you can run anywhere. It's Golang, so it compiles for Intel, ARM, Windows even, so you can run these components wherever you like. The database, etcd, which is where Kubernetes stores information, it's technically not part of Kubernetes itself. etcd is an independent project developed at CoreOS way before Kubernetes, really. And you can swap etcd with another database. It's really hard to do. Don't do it. But there are actually projects that can change etcd with, for example, MongoDB or something else. But really, it's not part of Kubernetes core. And also, all this stuff that you need to run in the cloud, like cloud load balancer, they are really not part of Kubernetes. So Kubernetes is this: it's a control plane and a bunch of nodes. And the control plane controls the nodes through the kubelet. You interact only with Kubernetes API server. So this is one of the rules. This is one of the design foundation of Kubernetes. You will never ever need or want to or even allow to write directly to the database. So every CRUD, create, read, update, delete operation to the database is done through the API server. So that's one. So you can, of course, go into the etcd and change stuff, but that would be really against the few tenants of Kubernetes. So, and Kubernetes API server is where you interact with it. Then there's of course a scheduler that makes a decision where to run your application, and a controller, which is a very important part. I'll come back in a second. And the kubelet is really what used to call minion, right? So the API server tells kubelet what to do. run these containers, create this bridge, create this storage. Kubernetes reports back to the API server is everything right, or is there some problems? It's reported back by the Kubernetes to the API server. All the communication is all secured by TLS certificates. So it's a client server authentication. So it's very secure. It's used in all sort of environments. I think it's Phil runs Kubernetes clusters in every shop. People put it in ships. The Department of Defense runs Kubernetes on the F-16 fighters. The presentation, so if you can run there, I think it's ready to run in your environment. So this is the only YAML I'm gonna show. So the idea is we need this to run containers, and it's exactly what Kubernetes does, and run containers like a boss. But the concept of container in Kubernetes is, let's say, augmented or extended with the concept of pod. A pod being also a natural concept of an envelope around seeds, right? Similarly, a pod is an envelope around containers. That's very powerful because if you think about it, we can run containers next to each other, being part of the same pod, and we can do interesting things. Like one container in a pod can, for example, ship the logs to a log server, while the other container is serving pages. So you don't need to, in the same container, put both the log shipper and the web server. You can keep containers very, very single use or single purpose, and combine containers, put them together in a pod, in a multi-container pod, so you can perform complex activities or complex application together in a pod. The only rules is that a pod is indivisible, so it cannot be split over multiple hosts, as to run in the same on the same host. But on that, you can run 10 pods of the same type all over your infrastructure. So that's the simplest YAML you can think of. YAML is it stands for yet another. Single host can run multiple pods, of course. So, like, as long as the host has capacity, you can run any number of pods on a single host. So I've seen this. There's some people that think I should run one pod per host, especially when they have like this huge, humongous application for machine learning, for example. It is okay. I mean, I see where it comes from. People want to, have this equivalency between one pod, one host, but that's kind of going back to the VM paradigm, right? So a pod is kind of a Docker Compose. If you come from Docker, a pod, it's what you can describe with a Docker Compose. And in fact, like this YAML definition, this pod definition, it's easily translated in a Docker Compose, and there's actually a translator that can take a Docker Compose is again written in YAML, and describes application in Docker Swarm, which is the competing HTML and XML, but it's just more easy to the eye than XML, I would say. And it's very sort of English, and the only annoying thing is that you have to really be careful with the spaces. So you have to move spaces to the right every time you want to nest keys under key. Docker Compose actually runs multiple containers, not just one. So you can have a Docker Compose file with the database, the application, and so on and so forth. Necessarily, you can do the same with the pod definition. But I'm not going to go too deep in details. So what is Kubernetes? The core component of Kubernetes is control loop. It's a concept born in industrial environments where systems need to be controlled in the loop, right? So you have a desired state, a set point, you give it to a controller, the controller analyzes, measures the existing environment, and tries to and takes remediation action. So the desired the actual state coincides with the desired state. So this is all Kubernetes does exactly this. It's a brain, it's a controller, right? So the brain of Kubernetes continuously monitors the situation, continuously monitor the current state of the cluster, compares it with your desired state, which is in database, because you through the API server, you wrote that in the database, and steers the cluster, moves, takes actions like I'm going to start a pod, I'm going to delete a pod, I'm going to move this pod around, I'm going to do something so the desired state is it's as close as possible to the actual state, or the other way around. So what we call it is like self-driving clusters or self-driving application. So like a self-driving car that responds to external stimuli, responds to changing external conditions with movements, steer a car in one direction or another. The cluster does exactly this. You lose a node, you get a node, or you scale up an application. Things change all the time. This is the cloud native way, right? So nothing is ever the same. Nothing is ever constant. The only constant is change, and that's what Kubernetes does. Like a change and make sure that you are happy with the results, and as in, I want this application to run with these specifications. Go make it happen. The late Dan Kohn, unfortunately, passed away last year, but in Barcelona defined or called Kubernetes a platform to build platforms. So all these things that makes Kubernetes amazing and awesome, they are useless unless you use them to build something that is good for you, right? So, and that's where the value of Kubernetes is, that you take it and you build something on top, and that something on top it's even more awesome because it's built on a good foundation. So this is what you have to see Kubernetes for. You take these layers and then you can build on top something amazing, and that's the whole point. I wanted to add like a mandatory meme slides. So the funniest is, I mean, they're all funny. There's actually a Memenetes Twitter account is also very, very fun. But it's all hype, right? So, and don't get me wrong. There's a lot of hype, a lot of people pretending Kubernetes is gonna fix everything. It doesn't fix everything, because it's like electricity, right? So it's all good, but you should use it for also in a good way, or you get electrocuted, right? So it's all about how you use things and how you put them together. So it's not gonna save you from bad code or bad applications or bad practices. Like if you don't have CI/CD, if you don't do DevOps, why even thinking about Kubernetes, right? So you gotta fix your house first, and then adopt a new technology. So, and now this is it. So we got Kubernetes, and then so Kubernetes was again released on GitHub end of 2014. I think it was announced at the Vozza conference. So Google put it on GitHub, and then everybody was thinking, hey, this is good. Let's try not to turn into yet another failed commercial enterprise. And that's where the Cloud Native Computing Foundation was born. So the whole point of the very mission of the Cloud Native Computing Foundation is to foster the adoption of cloud native technology, of which Kubernetes is really the keystone, the the central the point, the central technology to cloud native. So cloud native was born right after the open source of Kubernetes to manage the project in the beginning. So in the beginning, there was only one project, Kubernetes. It was spin-off as let's say a daughter foundation of the Linux Foundation. So Linux Foundation has been around for 15 years, I think, maybe 18 years. So Cloud Native Computing Foundation is really a part of the Linux Foundation. It's a non-for-profit. All the money they make, it goes back to the foundation, and their mission is to really make sure that everybody understands Kubernetes. So they work on they have certifications, free courses, they offer trainings, and so on and so forth. They make sure that the communities get together. So they organize KubeCon, they organize webinars every week. They run the community around this. So and this is the natural evolution of all this technology I talked about in the beginning, from some zones up to Docker containers and Kubernetes. This is the classical thing. You ask 10 people what is cloud native, you get 11 answers, right? So this is one way to see this. I understand. I agree that it's not. It doesn't really nail it, but gives you some idea, right? So you want to be cloud native. You can be cloud native with on-premise or bare metal machines. You ask Packet.net, great people. They do cloud native with bare metal, which is mind-blowing because they're really smart people. But it's hard, right? So you want to do, when you talk about cloud native, when you have a conversation about cloud native, you want to put your organization, your company on a path to cloud native, is that you want to start with what, right? So what is cloud native? And the technology here, like container, service mesh, microservices, they're all good for to talk about cloud native. Simon Sinek, the golden circle, this is what it is. How you do cloud native, right? So it's about like open source software. I'm gonna skip some slides here, but these are also from a slide deck you can download from CNCF. To achieve this, I mean, to be cloud native means that you avoid vendor lock-in, that you have unlimited scalability because you're in the cloud, and you can just request more resources from the cloud, but you need to manage them. Increase agility and maintainability, and resiliency, and so on, and efficiency and resource utilization. CNCF manages not only Kubernetes nowadays, so people realize, hey, this is good, right? So this is a governance model that works. And so people started to ask, hey, can our project be part of this? I say, sure, like the CNCF organize itself around like maintaining open source projects, right? So, and these are the 3 levels. So you start in the beginning, it's a sandbox. A lot of projects are in the sandbox phase, which means they're not really managed. I mean, they are part of the family, but they have to mature, right? So, and then a project become an incubator project, which means that it's really, it's getting to a point where there's a strong community around it. CNCF decided that this is good, and then they of course like take they help the project get in the right governance, the right marketing, and of course like and the very last stage is to become a graduated project for CNCF, which means that a project is so mature that it's becoming adopted left and right. So things like Kubernetes, Prometheus, TCD by now, and a bunch of others, Fluentd, they are graduated projects, as in, that's it. CNCF and the community around it swears by this project to be mature. So CNCF maintains a cloud native trail map, sort of map to guide you through adoption of cloud native technologies. They got this landscape, which is very overwhelming, but it's still You can pick and choose what is good for you, what you need for your own cloud native journey, or you can ask around. And ask if you ask the vendors, of course, that they have the best product out there, but there's also open source projects that are really good. So why you want to do it? To sum it up, resource efficiency, resiliency, multi-cloud. So it's easy to move around because Kubernetes is the kernel of the cloud, they call it, right? So the Linux of the cloud. You more or less you can be on an Ubuntu machine or a CentOS machine, but the kernel is the same, right? I mean, more or less, with little differences, but you know that you can run ELF binary wherever you are without really thinking, am I running on CentOS or Ubuntu? Same thing, if you're running Kubernetes in your cloud, you can take your application, move it to another cloud. It's going to run for sure. Maybe something has to be adapted, like load balancers or the way the cloud manage storage, but you can be sure that Kubernetes is the same anywhere you run it, and also on premise, of course. So this is one of the reasons people adopt this. So to, you avoid vendor lock-in. You can argue by locking yourself in an open source technology like Kubernetes, but it's a good. There's no way to avoid lock-in at all, but at least it's a good thing to have. At least that's my opinion. So why then you want to, get out of your comfort zone and do some magic with Kubernetes? And that's my take. Some people may differ. So the power of community. So it's not Kubernetes, really the people. The code is the code. It's just a bunch of Golang libraries, and you can reuse it. It's awesome code, by the way, and it's also extendable. I haven't talked about operators and stuff like that, but the best part of Kubernetes is that it's not really a monolith. You can just put stuff on it, and they just works magically. But the real value is the people, right? So why am I here? Why am I talking about this? Because I love the project, I love the tech, but I love the people around it even more, and I want to be part. So Kubernetes can be this, Kubernetes, other cloud native technology, other projects can be the initiator of this opening up of your organization to the open source world and to the community. So where do you engage in communities? Well, I got a few links for you. So we used to be all on meetup.com. We still are, to be honest with you. So after the Corona crisis, we stopped really organizing in-person meeting, of course, but also we don't do much of this webinar virtual meetups, because we are just waiting for our community. I'm talking about the Dutch Kubernetes community. We're just waiting for the right time to meet again. So when it's safe and everybody can come and enjoy a beer in company. But until then, we're not gonna do anything. We're not gonna be. We hang out around Slack, so you can join Slack, the Kubernetes, and hang around and come and say hi to NL users. And we are slowly migrating to the CNCF own, let's say, meetup website called community.co, which is awesome. But we haven't really, at the moment we were migrating, everything fell over, and we didn't really complete the migration. But it is where we're gonna announce the next meetup, I hope soon. And that's where we can have fun. This was in 2019. We organized the first Kubernetes Community Days Amsterdam. So CNCF organized KubeCon, which is a big event 3 times a year. But they gave us the blessing to organize this local events, and these are the people help me out, and they're amazing people. I don't know, they are not on the call, unfortunately, but they help organize this. It was super cool. And of course, like this was the first Kubernetes community day in the world and the last so far. So because after this, a lot of cities around the world reach out to us to organize one, but then of course, like in February 2020, everything stopped and we didn't do much about it. And so stay tuned because we're coming back in 2022, we hope. And you're welcome to come and help out next edition. So that's all I have, really. Like it's all about the people. It's all about orchestrating containers at scale. But in the end, it's the power of community that brings together the people around the technology. So any question? We have like a few minutes left.
Cool. Well, thanks for that, Alessandro. Really good, engaging presentation. I enjoyed that. I'm sure we've got a number of questions in there. I think Gopala has just posted one in the chat.
Yeah. Yeah.
Oh, yeah.
Yeah, Alessandro. Yeah, I typed it there, but I can just
Sure.
Yeah. So I come from the banking background. So most of the products are vendor products. So they are not built cloud native. So the only option that we have is we have to run them cloud native. I'm just wondering if these problems were already solved by the industry and some patterns or a book you could suggest, which had dealt with running legacy applications in a cloud aware environment or make them cloud aware.
Yeah. So it's a good question. So because you have this legacy application, it doesn't stop you to start your journey in cloud native. So you can wrap your application around a container, and it's not difficult at all. I mean, I've seen COBOL application and all sorts of legacy stuff, even entire mainframe recreated inside Kubernetes. But you can take your application within .NET or whatever and put it in a container, and then you can manage the application, even if it's in itself is not cloud native, but you can build a cloud native garden around it so you can manage it better. It's not ideal. You wish you could have everything ready, a microservice and everything. This is not the reality. What we see is that there's some things you can go and microservice-sized, and many others instead you have to leave them alone. But it doesn't mean that you're still locked into running them on 10 years old hardware, right? So you can run them in Kubernetes, and it's more trouble, but it's a reality. So, and banking are adopting Kubernetes at scale, and probably your banking application already runs in Kubernetes somehow. So it's secure. So there's some question about security. If I can answer that. So, and I mean, as a nice segue into security. So security in Kubernetes, it's very good. So we haven't had a CVE what CVE stands for? Well, so a security incident in Kubernetes for a couple of years, like an important one for a couple of years. So because it's open source, common vulnerability enumeration. Yeah. So thanks. Okay, so some definition of CV. So because it's open source, there's a lot of eyes on it, and the code is there. There's a problem. Trust me, a lot of people are gonna look into it and gonna release a security fix very quickly. Is it completely secure? You can't say that about any system, right? So it's an illusion having a perfectly isolated system. Actually, you could run Kubernetes in an air gap environment. We do that for many customers. So you can isolate completely Kubernetes and have it run in your own fenced off environment. But it's secured by default. I mean, there's a lot of effort. Kubernetes is managed by, technically, it's managed by special interest groups, sort of like they take a little piece of Kubernetes and they own that. So there's a SIG for network, SIG for storage. SIG security is really, really good. And they published, I'll find a link, a security assessment of Kubernetes itself, which pass all sort of requirements like FIPS and PPP. I mean, the US government is adopting Kubernetes. I mean, they put it literally in F-16 fighter. So if it's good for them, so all sort of, notably, SolarWinds wasn't running Kubernetes. So that's maybe that says something about open source security versus closed source security, right? So for me, it's clear open source means more secure, but you may argue that it's not. There is people arguing against it, but yeah. Containers can be immutable, so you got all the way to lock down containers, as in you can disable all sorts of escalation, all sorts of writing to the file system. There's an entire industry of container security, and names come to mind like Aquasec and Snyk and you name it. They do awesome job in container scanning, so image scanning, static image scanning, and runtime container scanning. So if you're not adopting this kind of basic stuff, you really the CNCF also, it's taking care of it because it just released last November an exam, a certification, certified Kubernetes security specialist, which I passed last month, and it's pretty awesome. It's very intense. So if you want to, if you need help passing the exam, I also have a blog post. I'll post the link soon. But you can. So CNCF takes security very seriously. Yeah, there's an open issue. It was this the 9945 is the exposing service thing. Depends, because yeah, I mean, but yeah, it's we are serious about security in Kubernetes land. So it's yeah, Ian Coldwater, if you find his presentation online, is a great guy, and he eviscerate everything about security in containers. So yeah. Any more questions?
No, I think we've had some good questions there. So thanks, guys, for your contributions. But yeah, some people have had to go and jump off the call. But what I'd like to do is a bit of a short request, really. If Alessandro, if you could stop sharing the presentation, and people could get their cameras on just for 1 second, because what I'd usually like to do in person is give Alessandro a round of applause, but given that the climate we're in and we're doing this virtually, it's quite difficult to do that. So if everyone could just give Alessandro a round of applause or a jazz hands, that'd be really, really appreciated. Great job, Alessandro.
Thank you, Leroy. That was and have a great weekend, everybody.
Yeah, definitely. Look, thanks, guys. If you've enjoyed this, you can find us on LinkedIn. I'm connected to most people. So yeah, if you could, share and pass the word, that'd be great. And look, we will have a recording of this, which will get sent around, and you can rewatch back if needed. But again, thanks for the time, and have a great weekend.
All right.
Yeah, thank you.
Bye.
Have a nice week.
Thanks.
Thank you.